Right. So when we talk about our fundamental physics, we have to go ahead and go over our certain particles, right? So when we talk about particles, um, we have two families of particles. Okay, we have got leptons and we have got hadrons. Let me type this out as I say it. We have got leptons and we have got hadrons. Okay, what are leptons? Leptons are particles that are unaffected by strong nuclear force. Leptons are particles that are unaffected by strong nuclear force. Examples of leptons would be your electrons and your electrons and your neutrinos. Okay, not neutrons, neutrinos. Hadrons, on the other hand, when we talk about our hadrons, so our hadrons are particles that are affected by strong nuclear force. An example is going to be your protons and your neutrons. Now, when we talk about our leptons, so leptons, when we go ahead and talk about it, we have to go ahead. So we've got leptons and we have got hadrons, and then we have got our quarks, right? So when we go ahead and talk about it in our hadron, so by the way, your hadrons, if you remember, if you've heard of the large hadron collider, the one that's over there in your Switzerland, right? So in your Geneva. So over there, you have the Large Hadron Collider, so that they are basically working with these particles, right? They're basically working with these particles. If you're interested in physics, you can go ahead and you can actually take a look into it. It's a particle accelerator that they're using to accelerate different particles and try to prove different theories. Now, when we talk about our hadrons, in our hadrons, they can be lots of different particles, right? To figure out the complicated picture of the hadron family, to figure out the complicated picture of your entire hadron theory, they came up with a few different particles, and the scientists called those particle quarks. Okay, so quarks are particles that are member of the hadron family. Now, when we go ahead and talk about it, there are certain features of quarks that are surprising, right? For example, quarks have a charge less than the fundamental charge E, meaning that our charge E was 1.6 into 10 raised to power negative 19. Their charge is less than 1.6 into 10 raised to power negative 9, right? Along with that, when we go ahead and talk about it, when we talk about it, your there are 6 types of quark, right? And each is associated with an antiquark. So we have a quark, we've got 6 different types of quark, and each quark is also going to have a specific antiquark, right? So let me go ahead and let me tell you about the different types of quark and the different types of antiquark. So let's make a table and let's do this 1 second. Fine. Okay. Now, first, let me tell you guys about the different quarks that we have. Okay. So the different quarks that we have are, we have up, down, charm, strange, top, and bottom. So up, down. We have up, down, charm, strange, top, and bottom. Now, let's go ahead and discuss the different features of it. What is the symbol for up? The symbol for up is U. Okay. What is the charge on up? The charge is plus 2 upon 3 E, meaning E stands for 1.6 into 10 raised to power negative 19. I told you that quarks have a charge less than E. So 2/3 of E. 2 upon 3 divided by 1.6 into 10 raised to power negative 19. That is the charge of up, and it's going to be a positive charge. What is the anti-quark? Remember, I told you each quark has an anti-quark. So the anti-quark is going to be anti-up. Anti-up. And finally, what is the symbol of anti-up? The symbol of anti-up is a U with a dash on the top. And the charge on the anti-up is minus 2 upon 3 E. Okay. Now, let's go ahead and talk about the next one, that is down. The symbol for down is D. The charge on D is minus 1 upon 3 E. The anti-quark for this is anti-down. The symbol for anti-down is D dash. And the charge on D dash or anti-down is plus 1 upon 3 E. Similarly, we have a charm. The symbol for charm is C. The charge is the same as up, plus 2 upon 3 E. The anti-quark is going to be anti-charm, right? The symbol is going to be C dash, and the anti-quark is going to have a charge of minus 2 upon 3 E. Then we have strange. Strange, when you're going to go ahead and talk about it, symbol is S. This is minus 1 upon 3 E. Anti-S is going, or anti-strange is going to be your anti-quark. S dash is going to be the symbol for the anti-quark, and plus 1 upon 3 E is going to be the charge of strange. Then we have top, which is T. The charge is plus 2 upon 3 E, right? The anti-quark is anti-top. The symbol for this is basically going to be your T dash. And the charge is going to be minus 2 upon 3 E for your anti-quark. Bottom is B. This is going to be minus 1 upon 3 E. It's going to be anti-bottom as the anti-quark. This is basically going to have the symbol of B dash, and plus 1 upon 3 E is going to be the charge on the anti-quark. So all of these are basically from the family of your hadrons, right? So hadrons are those particles that are affected by nuclear forces. So all of these particles are basically affected by your nuclear forces. And when we go ahead and we talk about it, these are the different quarks or the different families that you can find inside the hadrons. So quarks are basically you can say found in the hadrons, and there can be different type of quarks. So this is something you will have to go ahead and learn. So in addition to the property of charge, that was that their charge is less than E, quarks also have the property of strangeness, charm, upness, downness, right? But once again, you don't have to go ahead into details of any of these. But if you do decide to follow particle physics in the future, you would go ahead and take a look into it. Other than that, you also have two ways in which the quarks can combine to produce a hadron. Okay, so the quarks can combine to give you hadrons. There are two ways in which quarks can combine. There are two ways in which quarks can combine to give you hadrons. The two ways are, three quarks make up a class of hadrons that we call our baryons. So three quarks join together to give us a class of hadrons that we call baryons. Fine. And the second way that the quarks can join together is a quark and an anti-quark can make up a class. And this class is going to be known as our mesons. Right? So when we talk about our barons, what is the example of a baron? Examples of a baron are protons and neutrons, right? How do we make a proton? Proton is made up of two up quarks and one down quark, right? Two up. So a proton, for example, is made up of two up and one down. So this is made up of three quarks, right? So this is a baryon. Along with that, for example, we have neutron. So a neutron is going to be made up of your one up quark and two down quark. So these are example of your barons. Then what about our mesons? So in our mesons, we have different types. Let me go ahead and write down the symbols for this. In our mesons, we have pi plus, right? Pi plus is a particle. Pi plus meson is made up of one quark and a down anti-quark. So one quark, one up quark, and one down anti-quark, which is anti-down, right? So I'm just going to write down anti-down. One up and one anti-down. So this is one quark combining with an anti-quark. So it will give you pi plus, which is going to go ahead and it's basically going to be your, meson. Another meson we have is sigma, right? So when we go ahead and talk about it, this is composed of, again, a quark and an anti-quark, okay? So when we go ahead and talk about it, a quark is going to be, for example, it's made of a strange quark, and the anti-quark is basically going to be anti-strange. So both of these are examples of your mesons, right? So we have got our barons and we've got mesons. So barons and mesons are classes of your hadrons, and inside our barons and mesons, we've got different quarks joining together to give us these particular questions. These particular quarks. Any confusion? Is this making sense?
Yes,
Sorry, can you say it again?
Miss, we're supposed to memorize these, yeah? Like the...
Yes, it's a lot of memorization. Okay, give me 1 second, 1 second. Let me just go through syllabus and make sure I didn't miss anything. Okay, yeah. One
Miss,
thing now, yeah.
for the charge you wrote for the anti-quarks,
Mm-hmm.
for the up-down charm. Is it the same thing but with the opposite
Yes,
symbol?
with the opposite, exactly. So up is anti-down, down is anti-down, charm is anti-charm, strange is
So
anti-strange, top
up
is
is 2 by 3?
so up is plus 2 by 3, yes, minus 2 by 3. So the value will be the same, the charge will change. It will go from plus to minus or minus to plus, whatever it is.
Okay. And for the
Okay,
strange, it's 1 by 3 or 4 by 3 over there?
1 by 3, 1 by 3. It's minus 1 by 3. I have written minus 1 by 3. I'll correct it. I'll write it properly. It's minus 1. Whoa. It's minus 1. Okay. Now, let's go ahead and discuss something really interesting that we talked about in beta decay. Let's link everything that we just studied to the topic of beta decay. Give me a second. Let me open up the beta decay portion. Because we can actually link this concept to something really interesting. Something I told you guys in radioactivity that now you guys will be able to understand better. Remember when we were talking about our beta decay and we talked about beta minus particle and we talked about beta plus particles, right? So when you go ahead and you talk about it, when you go ahead and talk about it, and a beta plus particle, right? So basically what was happening in a beta minus particle, we had a neutron. That neutron was splitting to give us a proton. It was splitting to give us an electron, and it was splitting to give us an anti-neutrino, right? Now, we know that a neutron is made up of up quark and 2 down quarks, right? The proton is made up of 2 up quarks and 2 down quarks. So when you go ahead and you talk about the entire concept, right? So during
Colin?
beta, I just repeated what we talked about earlier. Remember, I told you that
Is 2 up and 1 down?
your when you talk about a proton is made up of 2 up quarks and 1 down quark. Neutron is made up of 1 up, 2 down.
Yeah.
The proton is made up of 2 up and 1 down. Got it?
Okay.
When we go ahead and talk about it, now during beta decay, the quark composition of the decaying nucleus is going to change. The nucleus that is breaking down, its quark composition is going to change. In beta minus decay, where a neutron decays into a proton, so this neutron is breaking to give us a proton. The down quark changes into an up quark, right? If you take a look, remember, what did I just tell you? I just told you that when you talk about a neutron is what? A neutron is 1 up, 2 down. A proton, on the other hand, is what? A proton, on the other hand, is 2 up, 1 down, right? Now, what is happening? This is the neutron. The neutron is breaking. As the neutron is going to end up breaking, what is going to happen? So what is going to happen is this, that look, one of your down particles is changing into the up particles, right? As the neutron is breaking down, one of the up particles has changed into the down particle, right? So what is going to, when you're going to go ahead and talk about it, what is going to end up happening? That the composition of the quark has changed, right? The composition of the quark has changed. So okay, so this is in your the opposite will happen in your beta plus decay. So in beta minus decay, a neutron is splitting to give you a proton. So what is going to end up happening is this, that you're in beta minus decay, where the neutron decays into proton, what is happening? A down quark is changing into the up quark. So your quark composition of the nucleus is changing. In beta plus decay, a proton is breaking down. A proton is breaking down to give you a neutron. So one of your up quarks is turning into the down quarks. So again, your composition is basically changing. And when we're going to go ahead and we're going to write down the equation for this, the equation is going to be like this. Our down quark is turning into the up quark, and in the process you're losing an electron, right? Because you're producing an electron, so you're losing electron, and a down quark is turning into the up quark. This is what you would see in beta minus decay. In beta plus decay, you would see that the up one is turning into the down quark, and over here we won't have an electron, we will have an anti-electron or a positron. So now you guys can see that what we studied about quarks, you can see it over here in your topic of beta decay. And one more thing, one more interesting thing, this is the composition of neutron, right? Up, down, down. So what was the charge on the up quark, if anybody remembers? It was plus 2 upon 3, right?
Yeah.
Yeah.
And
Yeah.
what was the charge on the down quark? Minus 1 upon
Minus
3. So go ahead, do this. Plus 2 upon 3 minus 1 upon 3 minus 1 upon 3. What do we get?
4.3 minus 0.
Right. And what is the charge on a neutron? 0. So
Yeah.
now you know why the charge on a neutron is 0. Similarly, in a proton, we have plus 2 upon 3, plus 2 upon 3, minus 1 upon 3. What do you get when you do this?
One.
1. And what is the charge on a proton? Plus 1. Now you guys know why neutrons and protons have these charges, because of the quarks inside of them. So the quarks can add up to give you different charges. That's why proton is plus 1. That's why neutron is 0. And that is why in beta decay, a down quark is turning into an up quark. So the quark composition is changing. And in beta plus decay, the up quark is turning into the down quark. So again, decay is changing. This is all making sense. This is clear, right?
Yes, miss.
Okay, 1 second. Let me just confirm if we are all done or if there's anything else that we have to go over. Right, that's it. That is basically our topic of nuclear physics. So we are now done with the topic of nuclear physics. Let me go ahead and open up some questions on the topic, and let's go ahead and solve them. Sorry, guys, I thought I was not on mute and I was speaking. So, okay. The question basically states that a nucleus of sodium 22 decays by emitting a beta plus particle. A different nucleus is formed by the decay. State the name of another lepton that is produced by the decay. So a lepton were particles that were not affected by your nuclear forces, right? So when we are having a beta plus decay, what other lepton is produced?
Miss, what is a neutrino?
Neutrino, is a neutrino produced in a beta plus particle? Wasn't it in a beta minus?
Oh yes, anti-neutrino.
If I'm saying it wrong, you can correct me. If as far as I remember, a neutrino was coming out in beta minus.
Oh yeah, it was anti-neutrino, right?
Yeah, you were getting you were getting an anti-neutrino. You can simply say an electron. Okay, an electron is correct. Neutrino is also fine. Yeah, you're right. Actually, you can say neutrino because in our beta plus, beta minus, you were getting an anti-neutrino. You're right. We were getting an anti-neutrino. So in beta plus, you can say a neutrino. That is correct. Then they're saying determine the nuclear number and the proton number of the nucleus that is formed by the decay.
Miss,
Yeah.
number is 22 and proton is 10.
Yes, good job. Correct. The quark composition of a nucleon in the sodium 22 nucleus is changed during the discrete. Describe the change to the quark composition.
Um,
I told you, remember?
yeah. Miss, is this correct? Up,
Yeah,
down, chemistry, down.
correct. So it basically changes from up to down. Okay. Then they're saying a baron consists of quarks that are the same type, right? So they're saying the charge of the baron is minus 2e, where E is the elementary charge. Calculate in terms of the charge of each quark.
Miss, how do we do this?
Think about it. You guys know the charges on all of the quarks. You know that the baron is made up of 3 quarks, right? You know the charge on each quark. So what would be the charge on the quarks that would give you a total of minus 2e?
Okay. So we can or like we add 2 of the quarks.
Yeah.
And
You
then
could try by adding up your quarks and see which one is giving you the charge of minus 2e. Adding which of them is going to give you the charge of minus 2e. Remember, there are 3 quarks that you can add up because a baryon is made up of 3 quarks.
so we have up, down, and top.
Yeah, you have up, down,
Down.
top, bottom. You've got strange, you've got charm,
We need -2, right?
minus 2.
2 by 3. It's anti-up, anti-charm, and anti-top. Is it?
I'll tell you this is easy. It's only like 1 mark.
Yes, I did that. I added like the anti-up charges, charm and top, so it gives
You
minus.
don't have to add up the anti ones, right? Remember, it was not the anti ones that were actually going ahead and they were actually, doing it. Remember, it was the quarks. It was not the anti quarks, it was the quarks.
Oh, okay.
Quark in an antiquark was not giving you a baryon, it was giving you mesons. 3 quarks joining together was giving you a baryon. 1 quark and 1 anti-quark was giving you mesons.
Okay. So only from the quarks we add.
Yes. Remember, they're not even asking you to tell the type of quark, right? They're simply saying tell the charge on the quark. They have even told you that the quarks are the same. It's not even like it's composed of different quarks. It's composed of the same quarks. Look, the charge on a quark can either it's negative. So either it can be -1/3 or it can be -2/3. All 3 quarks are the same. So if all 3 quarks have a charge of -1/3, that gives us a total charge of -1. If all 3
-2
quarks
by
have a charge of -2/3, that gives us a total of -2. So all quarks must have a charge of -2/3. Making sense now?
yeah.
Now they're saying state the possible type of the quark.
Oh, so now the thing that I said that it should be because we have anti up as -2 by
No,
3.
again, you don't have to take a look at anti-quark. They're simply
Then
saying
up.
state the possible type of the quark. Your charge is -2/3. So simply tell me which quark would have a charge of -2/3. Not the anti-quark, which quark?
Quark is
From up, down, top, bottom, strange, charm, from all of these, which one has the charge of -2/3?
up.
Up was -2/3 plus 2/3.
So minus is in antis.
Not necessarily. Let me see if I
Then
still
we
have
add
that. Look, not necessarily. Hold on. Give me a second. Let me take a look.
it doesn't have -2.
1 second.
-2/3 is charm, so anti-charm.
It's -2/3. So -2/3, yes, you are right. It is an anti-up. it is in anti-charm, and it is in anti-down, anti-top as well. Yeah, so you're right. You can write down anti-up, anti-charm, or anti-top. Any of these would be correct. Any of these would be correct. You don't have to write down specifically just one. You can write down any of these.
Anti. Anti-top, charm, and up, right?
Anti-up, yeah. An unstable nucleus decays by emitting beta minus particle. Determine quantitatively the changes in A and Z when X decays.
Miss, you're
Good. A, what about A is going to be the same. What about Z?
Miss, you're not. Miss, you're not sharing your screen.
I'm not. You both can't see it. Okay, hold on 1 second. 1 second, 1 second, 1 second. I'll do a new share. Can you guys see? Hold on. Now, can you guys see? Can you guys see now? What do you guys think will be the answer to part A?
XDKs. Beta minus.
Did you guys get the answer?
Miss, that is the mass.
Z is not the mass, right? A is the mass. Z is the proton number.
Oh, Z if proton. Then Z
Yeah,
has. A is mass. But we don't know what's the charge.
you know it's a beta minus particle.
Okay, okay. So Z is +1 because it's a proton, as you said.
Yeah. So
And
think about it. it is losing an electron. If it is losing an electron, what should happen to the proton number?
Losing electron, it becomes +1.
Yes, Z
So
plus 1. Yeah. So you
yeah.
just write down Z plus 1. In beta plus decay, you are gaining an electron, right? So you are always going to do 1 minus. In beta minus decay, you're losing the electron. So you will add a proton number to it. In addition to beta minus particle, another lepton is emitted. State the name of the other lepton that is emitted.
In beta minus, another electron.
You can say anti-neutrino, remember? In beta
Yeah.
minus, we were getting a proton, a beta minus particle that was an electron, and an antineutrino. A particle P is composed of an up quark and a down antiquark. Calculate the charge Q of the particle P in terms of E, where E is the elementary charge.
Antineutrino. Neutrons. As for the previous question, it was
Antineutrino.
also we can either write the proton, electrons, and then antineutrino.
A proton is not a lepton. Proton is a hadron. Remember that. I was just telling you that in your beta minus emission, you get a beta minus particle, that's the electron. You get a hadron, the hadron is proton, and the lepton is antineutrino.
Oh, okay. Yeah, particles compared to an up quark and down quark. Charge. Well, up quark is 2/3. X 2/3. T dash is 1/3. Let's do we just add them?
Yeah.
Yes. 1.
Yeah, good job. Particle P belongs to two classes of particles. State the name of these two classes.
Particle P had baryons,
No, it's not a baron.
mesons, and
And barons and mesons come under what?
hadrons.
Hadrons. So you can say it's a meson
Yes,
and
but that comes under hadrons, right? So hadrons have like 2 baryons and mesons.
that doesn't mean that it's not okay. I'll give you an example. Let me give you an example from biology, because something you guys have studied since 8th grade, right? So we have got, for example, animal kingdom, and inside animal kingdom we have got our fishes and we've got our reptiles, right? They're different classes, but that does not mean that reptile is not an animal or fish is not an animal, right? So
Yeah.
just because it's a meson, that does not mean that in the end it is a hadron.
Okay.
So that's why. So even though it's a classification under meson, that's still going to make it a hadron. So even though reptiles are a classification under the animal kingdom, but they are still an animal, right?
Yeah.
So you can still go ahead and say that. So you can say hadron over here. That's also completely correct. A nucleus of cesium decays by emitting a beta minus particle to produce a nucleus of an element X and an antineutrino. The decay is represented by this. State the number represented by each of the following letters.
Beta minus has, it will be 0, P 0, because it would stay unchanged, I think. Yes, I don't get this.
Please, can you explain this?
Minus and the antineutrino.
I'm so sorry, guys. I did not realize I was on mute. I don't even know how I was on mute. Okay, look, what is going to happen over here is that on our beta minus particle, the mass is 0, right? The charge is, or the proton number is -1 because they don't have a proton, they're an electron, so they're -1, right? When we talk about Q, Q is going to be 137. It will not change. It will remain the same. As for our proton number, so in beta minus emission, proton number increases by 1, right? So basically, what we do is, so if you guys remember making these equations, right? Alpha decay, beta decay, we always used to subtract, right? So 55 minus -1 will give you 56. So the proton number will increase to 56. Making sense?
Yes, miss.
Yeah.
Next, they're saying, state the name of a group of particles that includes the beta minus particle and the antineutrino. What do you guys think? What's the name of the group of particles?
It has antineutrino.
And the beta minus particle.
Miss Hadrons.
No, it's lepton.
Hadrons has neutron.
Yes,
okay,
Is
lepton.
how lepton? It has neutron.
Anti-neutrino. It's not a neutron, it's a neutrino. Neutrino is not a neutron.
Oh, so
Neutrino is
neutrino, the
different.
antineutrino.
Yes, neutrinos and antineutrinos are leptons. Antineutrino is produced in beta minus decay. Neutrinos are produced in beta plus decay.
Okay.
A particle Y has quark composition of D, where D represents the down mark. A particle C has quark composition of UD, where U represents an up antiquark. So the charges of particles Y and Z are equal.
Minus D. Particle Y is -1,
Mm-hmm.
and particle Z is also -1.
Yes, good job. So that's going to be -1/3 plus -1/3 plus -1/3 particle Y, and
Okay,
particle Z is going to be -2/3 -1/3, which is also going to give you your 1. State and explain which particle is a meson and which particle is a baryon.
Meson is quark and anti-quark.
Yeah.
So we have U and D. So particle Z is a meson.
Correct.
And
And
baryon is all three quarks are added up, so it's particle Y.
good job. Correct. Okay, so we will go ahead and